So if you've ever done any game development in Flash, you're probably familiar with the concept of sprite sheets. And this is essentially taking a certain animation and extracting every frame of that animation and putting it onto a single bitmap so that at runtime you can actually take the individual frames out of that bitmap and essentially paste it into, in Flash, a bitmap data. And this was known as blitting if you're creating a game using blitting. Well, those same concepts apply when we're working with Canvas. And now I'm going to show you how you would incorporate an animation sprite sheet into your Canvas projects. So in the exercise files, there's an image called sprite_sheet.png. And this contains an animation sequence created by Chris Georginas, who's one of the top Flash character animators. So with this sprite sheet, essentially, we need to embed this and actually extract each of the individual frames and show them in succession to essentially create our animation. So over here in Sublime Text, I've already set up my canvas, set it 800 by 600. And in the initialization function, I've actually got a reference to the context. I've defined this variable outside of the init function. That way I can actually use it in other parts of my JavaScript. So what I want to do up here is when we first come into the page, I want to load in that sprite sheet PNG. So what I'm going to do is to create a variable called img is equal to new image. And then I'm going to set the source on that. So image.src is equal to sprite_sheet.png. And this will immediately start loading that image in. And then once the image is finished loading, I'm going to listen for the onload event here, which is going to fire as soon as my image is finished loading. And I'm going to have it call a function called draw. And this is the function that's going to be called repetitively to actually draw out my animation. So I'm going to define that function now. In this function, we're going to be using the request animation frame API to handle our animation loop. So I need to import that at the top. So I'm going to put in that script tag. Now I have that JavaScript file on the desktop along with this HTML file. So I'm just going to import it, raf.javascript. And if you need to look back at the tutorial on request animation frame, that's where we created this JavaScript file. So the first thing I'm going to do in the draw function is to call the request animation frame and pass in this draw function. And again, this is what will create our loop. And again, all of this is going to be started once our image is finished loading. So I need to first create some variables up here that I'm going to need. So first thing I need to do is to keep a count of which frame I'm currently on. And I'm going to call that variable count. And I'm going to set it initially to 0 because it's going to be at frame 0 when we first come into the animation. And I'm going to create two other variables, one called x and one called y. And that's going to hold the value for where in our big sprite sheet do we actually want to extract the pixels from. And we're going to be calculating that down in the draw function. Okay, so now I want to calculate that x and the y value. Well, we can look at our sprite sheet. So let me actually go to the desktop here and open up that sprite sheet again. So we know some things about it. So we actually have 5 animation frames across. And we also know that the total number of animation frames is 150. So we can use that knowledge to write our code to extract the correct frame. So the first thing I'm going to do is to calculate the x position of where we want to extract that frame. So x is equal to, and now we're going to take that count variable, which tells us what frame number we're currently on, and we're going to use the modulus operator, which is essentially saying divide count by 9 and return what the remainder is when that happens. And I'm going to multiply that value by 212. And the reason why is because each frame of the animation is actually 212 pixels wide by 201 pixels high. They're all the same exact size in the sprite sheet. So this will actually give me the correct x position for where to pull out those pixels. So now we need to calculate the y value. So for the y value, we're going to take the current count variable and divide it by 9. Because essentially for each 9 frames across, we need to go another 201 pixels down on the y-axis. So what I need to do, because this could obviously conceivably be a decimal number, I need to wrap that in the math.floor function. And that will essentially round this value down that comes out. Now this will give me essentially the row number. I need to now multiply that by the actual height of one of the frames, and that's 201 pixels high. So with these two lines, I've essentially figured out, based on that count variable, where exactly the x and the y position is for the frame that I need to extract. So to actually extract that image and display it, I'm going to use the draw image function, which we used in the last movie. So ctx.drawImage, and first we pass in what image we actually want to draw into here. Well, that's the img variable. And now we need to give the starting x and the y position for what pixels we want to extract from the sprite sheet. Well, that's those values that we just calculated for x and y. Now the width and the height for how many pixels to extract, well, we know each frame is 212 by 201. Now the next thing we say is, where in our canvas do we want to paste these pixels? Well, we're just going to paste them at 0, 0. And now lastly, the width and the height for essentially the scale, we're just going to put in the actual width and the height of the frame, which is 212 and 201. So now we need to increment our count variable every time it comes into this. So for each new frame, we need to increment count. But we need to make sure that we don't go over the number of frames that are available in the sprite sheet. So let's do a simple if statement here. We're going to say if count is equal to 149, because remember, we're starting the count at 0 and there's 150 frames. So if that's true, set count back to 0. Else count plus plus. So essentially, if count is at the end of our frames, let's set it back to 0 so the animation loops again. If not, let's increment that count variable. So let's save it now. We'll go over to the browser and refresh. Now you can see this is working. You can see our animation is playing the way that it should, but you'll notice that we're not actually clearing the canvas before the next frame. So all the frames are being drawn on top of one another, which can actually lead to some really cool effects if you're trying to do kind of special effects. But what we actually need to do is to clear that canvas before we start drawing again. And to do that, we're going to come up right under the request animation frame, and we're going to call the clear rect method of the canvas context. So context.clearRect, and we can give a specific rectangle of the canvas to clear. So in our case, we're going to start at 0, 0, and x and y of 0, 0, and we're just going to erase 212 pixels by 201 pixels. And again, that's the size of our actual animation. There's no sense in clearing the entire 800 by 600 canvas because there's nothing being drawn on the other pixels. So now if I go back to the browser and refresh, we can see now we have our animation playing from our sprite sheet in a looping fashion. And there's actually some bubbles here you can't really see because of the white background. But you can see now how you would go about implementing sprite sheet animation. Now it is worth noting that there's a lot of frameworks out there that will handle this for you. There's one called Easel.js created by Grant Skinner, which I'll be talking about later in the course, which makes it really easy to incorporate things like sprite sheets. But again, to create a sprite sheet based animation, it's nothing more than embedding or drawing an image. You're just changing the image that's being drawn on every frame.